Okay, and I'll point you. I want to go back a little bit so now, assuming you didn't close your out before lunch, or if you did, just rerun example on the same wiki page. So we've been working off this wiki page, which is the quick start. That allows you to do the installation, and it does have the quick example to allow you to have one fit object. So as soon as you have a fit, you'll be thinking, okay, I want to get it out to do something else. If you don't want to use out to continue analysis, or you want to just send the track to someone else to plot it, or whatever you want to do, you want to get some of the things out, then you just have to keep going and scroll down. There's a section called exporting the results of out, and it will require just a script that I've written. Basically, we've been doing this morning using the $sign to get to the different parts of a fit object. So a fit object will have the process track. It actually has the raw data as well, and the parameter estimates. All those are happily sitting in a fit object, so it's just the different components of it. But what if you just want a track? And that's basically what these things will do. So the first part is you have to right-click and download the script. It's called fit to CSV, which you can all do together. So right-click and save it. I'm downloading the script. Once you do it, there are a couple ways of when you use somebody else's script. There's two different ways to get set up. You can just open up the file and copy and paste everything into the R window, or you just drag and drop the file into your R window, or you do it through a command line called source. So there are three ways to do it, and this is the code way. So kind of rewinding, this morning we were talking about the work directory. So assuming you have set your work directory, you can dump this file that you just download into the work directory. So I will be able to see you actually do have a file in there. And if it does, all you need to do is to do a command called source. And that will basically say, I'll load this wherever in this file, and I will have the additional functionality that you have already written or prepared earlier. So in the same way, when you're working with your own data, you can always say off your script that you have all the out code that you've been running with an out.out extension. The next time you want, you can just dump the whole script in using the same command called source. Source will be just like, I'll read in whatever out command in that file, and I'll just recreate whatever you are running. So let me do that. Do I have a fit object? I do have a fit object. So you see, I already sourced my file. The way that I do, I cheated. I used the R interface, the Mac interface that able to source the file from a browser standpoint. If not, you can just specify the path, or if it's already in your working directory, you just have to give the file name. So you can do that. And what it does, it will load whatever functions I've written there, and the function actually called fit to CSV. So if you do this. Okay, now we have the additional function. What it does is extend some of our capacity to output stuff. Phil, are you up to speed in some of the running things? Or?
Possibly.
Okay, good.
Seems so.
Yeah, so remember, I still have the fit object. So what it does, this function will just take anything from fit and output into free files. So I'll go back to my workspace. So here, you can run it by saying supplying a fit to, you call the function with fit to CSV, and it will take in any fitted object and output 3 files, and it will have the A, B, and C files. A file will be all the track points, so it will be your entire track. You can send that to your friends. Model parameters, so it's B and C files are more the model related. Like if you want to know what the estimator at the end, and also the initialization, just the small things for myself essentially. I want to know how the model works and how I get it to work. So the two other files, B and C files, most people won't get to use it, but I usually will output all 3 files to it. So if you do run these based on your fit object, so I assume you still have fit in your workspace, it will dump these 3 files into your working directory. And you can open one up once you did it. Just do the same. And you actually can change it again with an argument. If you add a folder, you can dump it exactly where you want to be. Like the default is your working directory. So, and once you got it, try to open up that file with the track, which is the A file. So in my very messy setup, you see my free output files here. If you open up the CSV. This should look something like this. So, basically we'll give you the most probable track, MPL, MTT, non-net, and then the variance. The variance will allow you to calculate the compensant regions, and there's the other stuff. So it'll be tag long and tag lat will be your input lat long. And also your input SST, and this is the most probable SST. So you can see this is the model results, and that's just the tag results. So you get a file like this from A file. So if you're concerned mostly about the track, that's how you get it out. And you can do it for multiple objects, and you get the same set of files. So you can, if you like to use ArcGIS or whatever else to plot things, this is the file that you can use for the inputs. So that will cover getting things out of OWL. And if you're sick of OWL, then this is it. Then you're done with OWL right now. But I'm not. So again, it's like, you see, it's basically a lot of things we cover is from the quick start. We get through the installation, we run through the examples, and how to get it out. And I'll also point back to another page on there that will allow you to get the data in. So, like, I guess part of tonight's assignment for you guys would be, especially for those you have your own data, will be, there's a part called importing data here. And that covers a bit on set directory stuff, and also just functions to read data files. So there are other stuff in links to help you to read in your data. But essentially, our purpose is to get our data look like the 5 or 6 columns. The date stamp, basically date stamp, lat long, and SST, if you need SST, to be in a simple format so we can run our stuff. So that page will help you along. So again, if you go back to the wiki, it's basically near the top that you have those things. Okay, and yeah, so we cover how, with that, we cover how we get the data in. We ran the model, we ran KF track, which is used mostly for the Argos data, if you want to. Then we do UKFST, which uses sea surface temperature matching, apart from just lat long positions from manufacturer. And we cover how to at least get the files out of any fitted out objects. So now I'll just backtrack a bit and show you just 1 or 2 functions on the SST side. The default option is to use this data product. So just go here. And that's basically, you find the same link if you do this command. So this is the link. So this is our data sources where we get the optimally interpolated SST from NOAA. And this is the source site. If you want to learn anything more about this product, you can go through there, and you can see how they do the things. And this is, as this site suggests, the spatial coverage is a 1 by 1 degree box. So a certain degree of smoothing in there is actually, it works pretty well for our models because the trade-off between computational load and accuracy, this is a good place to start. If you ask me how SST resolution might change things, I'll refer you back to our publication, which I'll show quickly. To get to the publication, you go back to this resources, to the project home, and these are the key papers for the things that we've been talking about. And for this one, for the first paper, it will go in depth how the different SST might change your results. And it usually would not matter too much, the more stuff you throw at it, but it does help in keeping the tracks off land. The model by itself do not distinguish between land and ocean. We don't have a bathymetry mask to it. Like, we do it afterwards, and I'll show you how to do that. But by default, it doesn't. It can be, it's a bad thing because the program does not do it for you by default. But for me, it's a good thing because I can tell how, maybe at least biologically, how well the model is working. If it's able to keep the animal off land without me doing anything, then it's like, yes, that works out really well. So in a way, it provides me boundaries to work with when I change any parameters. Is there any way for me to make sense of why I do that? That would be one way. It's like, okay, maybe I can, when I do some parameter changes or use a better resolution SST, it's because it keeps the animal off land. So that's one way why being end up on land actually helped me out a little bit. So this paper, if you click on the link, you'll open the paper, and most of the figures there will show you three different set of SST products and how it changes the solution. Like, it's basically running almost a similar model, but just doing different resolution sea surface temperature products. So that's that. And I'm not going to walk through the graph, but yeah, that would be the paper to look at. And the way to use, okay, so now the next question is, if you don't like this SST product, what can you do? So the first thing is, there's actually another function in R we call get blended SST. So this will allow you to download another SST source, which will be high resolution. So we were operating at 1 degree squares. This one, I think will be 0.25 is or 0.1. I think it's 0.1 degree square. So you get 10 times more dense, and it will basically take you forever. So you have to be very patient, or at least you know kind of what you're running. And it's relying on another web server, and you can see actually the argument here. That's the web server that we're using to get the data. And yeah, the resolution can be 5 days or 8 days, and it will return to the file. Okay, so this is inbuilt, but what if you want to use your own? If you really want to use your own, then you just have to do a bit more work. Okay, so essentially, if you open up any one of SST files that you download, it comes in basically 3 columns. It will be latitude, longitude, and then SST values. So essentially, you can do the same as long as it follows a naming convention. So this type of file we call XYZ. So you have basically lat, long, and SST. So if you use your own SST source, you have to do a step of pre-processing. You have to get a bunch of text files that will have your design SST's product. And then on the file name, you just have to be able to name it in Julian days. So it's basically saying Julian day 1901 to Julian days 97 that will be using this file. So in the file name, you have to following this convention and the name. And so once you have this set of files in a folder, you can actually supply it into your model setup. And the way that you do that is to use this last argument in kfSST. You see there's a local SST folder equals to now. So all you need to do is supply this into, you just provide a path to where you store your SST. The way to do it, remember, I think I still have my lovely SST folder. So if your SST folder is sitting in there, you just have to supply that as an argument. So fits, there'll be local SST folder goes to my lovely folder. So that's how you use like your either your own source of SST or your pre-download SST. So remember, when we do the download process, you can actually save it to a physical directory instead of in the temporary directory. So you can just supply it in the same way. You can just put it, go there and look for the SST instead of going to the web. So that's the way you do it. Okay, so now we'll do something pretty fun from this point. We'll go down this site and we'll make sure we know how to get. So okay, finally you have your model, and somehow our fish is walking on land. It's like what you can do about it. There's a pro-processing step we call Biometric Correction. The idea is, say, as we know now, so we have this most probable track point, and there's an area around it. We know that it can be anywhere within that circle. So the biometric correction is basically you have to supply now not just, so you have your whole frame of data. So you have your lat, long, and now you will have a maximum depth. So you just have to add another column to be the maximum depth. So essentially, it will match against what the text sees, and within the circle, just try to find the place closest that will be resampling the biometric within that circle. So that method is described in this page, and the package goes along with it will do that process for you. So here is how you install it. So if you want to try installing it right now. So if you go back to the background, so those are the things that you built a point on. You can get over those. But you can just install this one, and it will load the package you want, essentially. And we'll run through one example to do that. So I think everyone got it, and we'll do a quick biometric correction. Like, too bad we put this new example pretty hastily. Like, we're in Hawaii, the points you see on land can't really see too well, but there are actually some points that's really close to land. When we plotted up, the points are too big, so it still look like on land, but essentially it's a template that you can set up and use. So if you go to the next page, so we were there at the first page doing this one. So, but this is an example on the next page that will step us through that. And the first few lines is loading the libraries and some data set, which maybe you can. Yeah, we'll probably just do it all together from the get-go, because this path, instead of using existing fit stuff, because this one is all nice and laid out. So run those few lines here, and you should do this line as well. Just copy and paste. There's some peculiarities with this NOAA server. When you try to download big data set, it doesn't like you. So you just do 2 or 3 times, and somehow they decide to like you. So it's like it's a very fair little boyfriend or girlfriend that you need to chase them up to several times before you start working. So do run that line a few times, and it should download the file. If for some reason that it fails, I have a backup plan, but let's see how far you can get along. Then let's just grab, we'll cheat and grab that step. So if you go to the source tab, you have to browse a little bit more. Just go, open a new tab, go to the source, go to trunk and support. And in the sample files, there's a big 241.r data. It's a big one, so click on that one and download that instead while you're downloading all the other stuff. It will only put any points not in the ocean back into the ocean. So that's the whole idea. So when we first fit the track, it doesn't know whether it's in the water on land. So if you have points on land, this extra step will put those points back into the ocean based on your maximum depth.